Welcome to IIT PAL Mathematics problem solving session. This is lecture number 3. In today's lecture, I will solve some more problems related with matrices and determinant. So let's start with problem number 1. Question: find the total number of distinct x belonging to R, that is the real numbers, for which x square 1 plus x cube 2x 4x square 1 plus 8x cube 3x 9x square 1 plus 27x cube is equals to 10. So we need to find the x which satisfies this determinant equation. So let's solve, and x has to be real number. Okay, so let's simplify let's break this determinant in two parts. The first part is x 2x 3x x square 4x square 9x square 1 1 1. This is the first determinant. The second determinant is x 2x 3x x square 4x square 9x square x cube 8x cube 27x cube. This is equals to 10. Okay, so now let's solve these determinants, simplify these determinants. Okay, so what I will do is I will take x common from the first determinant. I will take x column from the column 1 and x square from the column 2. So we get 1 2 3 1 4 9 1 1 1 plus I'll take x from column 1, x square from column 2, x cube from column 3, x into x square into x cube, and we get 1 2 3 1 4 9 1 8 27. This is equals to 10. Okay, so this implies this is x cube 1 into 4 minus 9 minus 1 into 2 minus 3 plus 1 into 18 minus 12. Okay, plus this is x to the power 6. Then now here I will take 2 common from the row 2 and 3 from the row 3. So 2 into 3 we get 1 1 1 1 2 4 1 3 9. This is equals to 10. Okay, this implies what do we get there? It's x cube to minus 5 plus 1 plus 6 plus 6 x to the power 6, and this is nothing but 1 into 18 minus 12 minus 1 to 9 minus 4 1 into 3 minus 2. This is equals to 10. Okay, so this implies that this is 2x cube plus 6x to the power 6, and this is 6 and minus 5 plus 1 is equals to 10. All right, so we get 12x6, right? So we have 2x cube plus 12 x to the power 6 is equals to 10. This implies 6x to the power 6 plus x cube minus 5 is equals to 0. So let's factorize it. So we get 6x to the power 6 plus 6x cube minus 5x cube minus 5 is equals to 0. This implies we get 6x to the power cube x cube plus 1 minus 5 x cube plus 1 is equals to 0. So this implies x cube plus 1 into 6x cube minus 5 is equals to 0. So this is 0, either x cube plus 1 is equals to 0 or 6x cube minus 5 is equals to 0 or both. Okay, so the solution of x cube plus 1 is equals to 0 or 6x cube minus 5 is equals to 0. Okay, so let's solve this. Let's find the roots of these two equations. So this I can further simplify it. So this is nothing but 5 by 6 to the power equals to 0. So here what I will do is I will just take some general form. See, for example, I will calculate the root of x cube plus a cube. What is that? This is nothing but x plus a, x square minus ax plus a square. So this is equals to 0. So this implies x is equals to minus a. This is the first root, and x is equals to for this quadratic equation we get a plus minus a square minus 4a square divided by 2. This is nothing but a plus minus a root 3 I divided by 2. Okay, so these things so x is equals to minus a and x is equals to a plus minus a root 3i divided by 2 are the roots of x cube plus a cube is equals to 0. So here if you see, we have only one real root, which is x is equals to minus a. Okay, so x cube plus a cube is equals to 0 has only one real root, which is x is equals to minus a. Similarly, x cube minus a cube is equals to 0 has only one real root given by x is equals to a. Okay, other two are complex one. Okay, so we can do the in the same way. So this means what? This implies x cube plus 1 equals to 0 has one real root, x is equals to minus 1, and x cube minus it was 5 by 6 is equals to 0 has a real root, x is equals to 5 by 6 to the power 1 3. Okay, so this implies we only get two real root for 1 for this equation, x square 1 plus x cube 2x 4x square 1 plus 8x cube 3x 9x square 1 plus 27x cube is equals to 10, and they are given by x is equals to -1 and x is equals to 5 by 6 to the power 1 by 3. So this is the final answer. Let's solve another problem. Okay, so let A is equals to 3. A is a 3 cross 3 matrix. 1 is alpha square 1 plus 2 alpha square 1 plus 3 alpha square 2 plus alpha square 2 plus 2 alpha square 2 plus 3 alpha square 3 plus alpha square 3 plus 2 alpha square 3 plus 3 alpha square. B 3 cross 3 matrix such that determinant of A is equals to -6 4 8 alpha, then what will be the value of alpha? Okay, so we need to first find a determinant in terms of alpha, and then we try to solve this equation. Okay, so let's do that. So determinant of A is nothing but, let's simplify those terms. So it is nothing but 1 plus 2 alpha plus alpha square 1 plus 4 alpha plus 4 alpha square. Third one is 1 plus 6 alpha plus 9 alpha square. Okay, then the second row 4 plus 4 alpha plus alpha square. Okay, and this is 4 plus 8 alpha plus 4 alpha square. This is 4 plus 6 alpha, no, it's a 12, sorry. This is 4 plus 12 alpha plus 9 alpha square. Okay, so let me just write this again. Sorry for that. Okay, so what was that? This is 4 plus 12 alpha plus 9 alpha square. Okay, the third row is 9 plus 6 alpha plus alpha square. Okay, then 9 plus 12 alpha plus 4 alpha square right? And then third entry is 9 plus 18 alpha, okay, plus 9 alpha square, 9 alpha square, okay. So this is 9, okay. So now this is the determinant A. So let's try to simplify it. Okay. So we'll make some elementary row operation. So what I will do is I will apply this operation. R2 is R2 minus R1. So that means we will subtract the row 1 with the row 2, and row 3 also will subtract row 1 with the row 3. So R3 goes to R3 minus R1. Okay. So as we know that with these elementary row operation, the determinant doesn't change. So this is nothing but, okay. So what is that? So this is there is no change in the first row. So we'll just write it. It is 1 plus 2 alpha plus alpha square, 1 plus 4 alpha plus 4 alpha square, okay, and 1 plus 6 alpha plus 9 alpha square. Then R2 is minus R1. So what we get? We get 3 plus 2 alpha. Here we get 3 plus 4 alpha. Here we get 3 plus 6 alpha. Okay, and third row is R3 minus R1. So we get 8 plus 4 alpha. Okay, and then 8 plus 8 alpha. Okay, and we get 8 plus 12 alpha. Okay, so this is what we get. Now we again make some changes. We again do some elementary row operations. So for example, if I multiply the second row by 2 and subtract it with the third row, so this is the operation I will do. R3 minus 2 R2. All right. Okay, so let's see what we get. So here there is no change in the first and second row. Determinant A is equals to, okay, there is no change in the first two rows. So 1 plus 2 alpha plus alpha square, 1 plus 4 alpha plus 4 alpha square, 1 plus 6 alpha plus 9 alpha square, okay. The second row is 3 plus 2 alpha, 3 plus 4 alpha, and 3 plus 6 alpha. Then the operation was R3 minus 2R2. So R3 minus 2R2 is we get, so alpha term will be knocked out. So we get here 2 and 2, and this is also 2. Okay, so let me just verify one more time. Yeah. Okay. So right. Let me just delete this. All right. So can we further simplify this? So yes, we can do. Now we'll do some column operation. For example, I will make this operation C2 goes to C2 minus C1, and C3 we will apply C3 minus C1. Okay, then let's see what we get. So we know that determinant value doesn't change, so there is no change in the first column. So 1 plus 2 alpha plus alpha square, 3 plus 2 alpha 2, and this is nothing but 2 alpha plus 3 alpha square, and this is 4 alpha plus 8 alpha square. This is 2 alpha and this is 4 alpha. Alright, and this one interval will be 0. This is also 0. Okay, so now we can just open the determinant. So this is nothing but we'll just open it across the third row. So this is nothing but 2 times 4 alpha into 2 alpha plus 3 alpha square minus 2 alpha into 4 alpha plus 8 alpha square, and this gives me 2 times 8 alpha square plus 16 alpha cube. Okay, so this is nothing but 8 alpha square plus 12 alpha cube minus 8 alpha square minus 16 alpha cube. Okay, and this is equals to 8 alpha square will be knocked out, so this is equals to minus 8 alpha cube. So the determinant of A is equals to minus 8 alpha cube. Okay, so in the question it is given that the determinant A is equals to minus 648 alpha. This implies minus 8 alpha cube is equals to minus 648 alpha. So this implies alpha cube minus 881. Okay, alpha is equals to 0. This implies alpha times alpha minus 9, alpha plus 9 is equals to 0. So this implies alpha values are 0, 9 and minus 9. So these are the 3 values of alpha for which that equation holds. So this is the final answer. Okay. Okay, so let's solve another problem. Question: let M and N be 2 3x3 matrices such that Mn is equals to Nm. Further, if M not equals to n square and m square equals to n to the power 4, show that the first part is determinant m square plus m n square equals to 0. The second part is there is a a 3x3 non-zero matrix U such that m square plus m n square U is zero matrix. Okay, so let's solve this problem. Answer: okay, so this is what is given. It is given that mn is equals to n m. Let's see what it gives us, right? So if I multiply so m n into n from the right, then mn square is equals to n m n, and now I can apply the mn is equals to nm here. So we get mn square is equals to okay, and this is equals to n square m. So we have mn square is equals to n square. Okay, so now take this is what is given. M square is equals to n to the power 4. So this implies m square minus n to the power 4 is zero matrix. So this 0 represents the zero matrix. Zero matrix is the matrix whose all entries are 0. Okay, so now let's try to do some manipulation in this equation. So I can always write m square minus m n square plus m n square minus n to the power 4 is equals to 0 matrix. This implies m I can take common here, then it is nothing but m minus n square. Here I will change mn square to the n square m from here. So I can write n square m minus n to the power 4 is equals to 0. So this implies m minus n square plus n square. If I take from here, then we'll get m minus n square is equals to 0. So we have m plus n square into m minus n square is 0. So let's call this equation number 1. Okay, so now consider two cases. Case 1, where determinant of m plus n square is 0. Okay, this implies, then the first part was that we need to prove that determinant of m square plus mn square to be 0. So this determinant I can write it as a determinant m into m plus n square. This is equals to determinant of m into determinant of m plus n square, and determinant of m plus n square we are considering to be 0. So this implies this is 0. So in this This 0 is the scalar, I know, so don't get confused with these zeros. All right, okay. So this determinant is 0, so that means the first part is done under this case. So there is but another case is also possible. That means case 2 is determinant of m plus n square not equals to 0. So these are the only two cases possible. So if this is the case, this implies m plus n square is invertible. That means this inverse exists. Okay, then we multiply equation 1 from the left with the m plus n inverse. Okay, this implies m plus n square inverse into m plus n square m minus n square to be equals to 0. All right, okay. So here what we did, we just multiplied m plus n square inverse to equation 1 from the left. So this gives identity matrix. So this implies that m minus n square is a 0 matrix. All right, so let me just summarize here. This implies that m is equals to n square, and this is not possible, right? Which is not possible because in the question it is given that m is not equals to n square, which is not possible. Okay, all right. So this implies that case 2 cannot occur. Because if it occurs, then we reach to the contradiction. Okay, so this implies that determinant of m square plus m n square is 0 as concluded in the under case 1. Okay, so the first part is done. Okay, so what is the second part? So let's prove the second part. In the second part, we need to show that there exists non-zero matrix U, all right, such that m square plus m n square U is equals to 0. So in the second part, we need to show that m square plus m n square U is equals to 0 for some non-zero matrix U. Okay, so this represents the 0 matrix, right? So I don't need to mention all the time. I think it is easier to follow. Okay, whenever there is a scalar, the 0 represents the scalar. Whenever on the other side it is a matrix, it represents the matrix. Okay, so that means we need to identify a non-zero matrix U for which this is true. Okay, so now let's go back to the equation 1. What was the equation number 1? From 1 we had this m plus n square into m minus n square is equals to 0. So now this implies you just multiply this by m. Okay, this implies m square plus m n square m minus n square is equals to 0. Okay, then define U, that non-zero matrix, as a m minus n square, which is not equals to 0 from the question, from the hypothesis of the question. Okay, this implies m square plus m square U is equals to 0 matrix. So this is what hence proved. Okay, yeah. So let's solve another problem. So let M is 3 cross 3 matrix given by 0 1 A 1 2 3 3 B 1, and its adjoint is given by adjoint M is given by minus 1 1 minus 1 okay. Second row is 8 minus 6 2 minus 5 3 minus 1, okay, where A and B are real numbers. A and B are real numbers. Okay, and then show that number 1 is A plus B equals to 3. Second part is adjoint M of inverse plus adjoint of M inverse is equals to minus M. The third part is if M into alpha beta gamma, which is 3 cross 1 vector, is equals to 1 2 3, then alpha minus beta plus gamma equals to 3. Okay, so this is the problem. So let's solve it. Answer. Okay, so given M is given, so adjoint is also given, and M has two entries which are A and B. So basically first let's try to compute A and B. So let's solve the first problem, first part. So here M is 0 1 A 1 2 3 3 B 1. All right, so what is the 1 1 cofactor of M? So this is nothing but the determinant of some matrix, which is obtained by deleting the first row and first column, so which is nothing but 2 3 B 1, the determinant of this submatrix. So this determinant is 2 minus 3B. Okay, so given we know the adjoint matrix, adjoint of M, so this 2 minus 3B, this implies 2 minus 3B should be equals to the 1 1 entry of adjoint M, right, which is nothing but minus 1. So this implies 3B is equals to 3, implies B is equals to 1. Okay, so B we have obtained. So now let's find the 3 1 cofactor of M, which is nothing but the determinant of submatrix obtained by deleting the third row and first column. So this is nothing but 1A 2 3 determinant of this 2 cross 2 matrix, and this is nothing but 3 minus 2a. Okay, so given so as we know that adjoint M is a transpose of a cofactor matrix, so this 3 1 cofactor will be stored in at the 1 3 place of adjoint M. So this implies that 3 minus 2a, this will be the 1 3 entry of adjoint M, which is nothing but minus 1. Alright, so this implies 2a is equals to 4, implies a is equals to 2. So a plus b is equals to 2 plus 1 is equals to 3. So first part is done. Okay, so let's go to second one. Okay, so this says that let me just write the expression: adjoint M inverse plus adjoint of M inverse, this is equals to minus M. So this is what we need to show. Okay, all right, given we know the a and b value, so using these values, what is M? M will be 0 1 2. In place of a, I will put 2 1 2 3 and 3 b1, so b is 1 3 1 1. So let's calculate. So determinant of M is nothing but 1 minus 9, so this is minus 1 into 1 minus 9 plus 2 into 1 minus 6, so this is nothing but 8 minus 10 is equals to minus 2. So determinant of M is equals to minus 2. Okay, so as we know that determinant of adjoint of M is nothing but the determinant of M whole square, because M is 3 cross 3, so it's a 4, which is not equals to 0. So this means that adjoint M matrix, it is invertible. All right, okay, so let's prove the expression. So we know that adjoint M into adjoint M inverse. So this is true for any two matrices, right? Which is nothing but identity matrix. All right. So what is adjoint M? Adjoint M is the determinant M into M inverse. Adjoint M inverse is equals to I. So this implies that we can multiply by M from both sides, from the left, so we get adjoint M inverse is equals to M upon determinant of M. So as we know that determinant of M is equals to 1 upon determinant of M inverse, so this is nothing but determinant of M inverse. I can also write this M inverse of inverse. Okay, so this is nothing but adjoint of M inverse. Okay, so what do we have? We have this relation: adjoint of M whole inverse is equals to M upon determinant of M is equals to adjoint M inverse. Okay, so this means adjoint M inverse plus adjoint of M inverse is equals to 2M upon determinant of M, and determinant of M is minus 2, so this is equals to minus M. So this is what we wanted to prove, right? So this implies, let me just write the last line, which is nothing but adjoint M inverse plus adjoint of M inverse is equals to minus M. So hence proved. Okay, so now let's go back to the third part. Let's solve the third one. Third one says that if M alpha beta gamma is equals to 1 2 3, then alpha minus beta plus gamma is equals to 3. Okay, so given determinant of M is minus 2, all right, so that means the M is invertible. So what is M inverse? M inverse is the adjoint M divided by determinant of M, right? So what is this? We know the adjoint matrix. I'll just divide that matrix by minus 2, so we get 1 by 2 minus 1 by 2, 1 by 2 minus 4, 3 minus 1 minus 5 by 2, so this is 5 by 2, this is minus 3 by 2, and this is 1 by 2. So this is the M inverse, right? Okay, so now let's use this relation, right? So M of alpha beta gamma is equals to 1 2 3. So this implies that alpha beta gamma is equals to M inverse 1 2 3, and if you multiply this column vector with the M inverse, we get, so let me just write it down, this M inverse again. So this is nothing but 1 by 2 minus 1 by 2, 1 by 2 minus 4, let me just check again, yeah, minus 4, 3 minus 1, 5 by 2 minus 3 by 2, 1 by 2 multiply with the 1 2 3. Okay, so what will be this? This is nothing but 1 by 2 minus 2, 3 2 5 1 6, 3 minus 2 3, 1 second, 4 minus 2 2 by 2, so 1, and this is minus 1 because minus 4 minus 5 plus 3 divided by 2, and this is 1. Okay, so this is what we get, alpha beta gamma is this. So this implies what? This implies alpha is 1, beta is minus 1, gamma is 1, and this implies alpha minus beta plus gamma is equals to 1 plus 1 2 plus 1 3. This is 3. So this is what we wanted to prove. Okay, so hence the third part is also done. Okay, so let's solve another problem. Let x belongs to real number and let p is equals to 1 1 1 0 2 2 0 0 3 and q is equals to 2x x 0 4 0 x x 6 and R is equals to PQ P inverse, then show that first part is determinant of R is equals to determinant of matrix 2x x 0 4 0 x x 5 plus 8. Second part is for x is equals to 0 if R times 1ab is equals to 6 times 1ab, then a plus b equals to 5. Okay, so let's solve this problem. Okay, so where do we start? So let's start with this R is equals to PQ P inverse. Okay, then determinant of R is nothing but determinant of P into determinant of Q into determinant of P inverse. As we know that determinant of P inverse is 1 upon determinant P, so this is nothing but determinant R is nothing but determinant of Q. Okay, so let's take Q matrix. So let's write the okay, let me just delete this. All right, so sorry, I'm making too much mistake. Determinant of R is equals to the determinant of Q. So what is the determinant of this matrix? What is the Q matrix? Let me write it: 2x x 0 4 0 x x and 6. So I'll just break 6 as a 5 plus 1. Okay, then I can break the determinant in two determinants, which is nothing but determinant of 2, and so here I can write it as a 0 plus 0. All right, then I can write it 2x x 0 4 0 x x 5 plus determinant of 2 0 x x 4 x 0 0 1. So determinant of this second matrix is what? This is just 8. If you just open through the third column, right, then this value is 8. So this is what we wanted to prove. So that means determinant of R is equals to determinant of 2 x x 0 4 0 x x 5 plus 8. So this is what we wanted to prove. All right, okay, so let's go to the part 2. Okay, so part 2 is that says that we need to take x is equals to 0. So if x is 0, then what will be the Q matrix? The Q matrix will be 2 0 0 0 4 0 0 0 6. All right, So this is the Q matrix we have. All right. So R is now we need to calculate the R explicitly. Remember R was P Q P inverse. So this means we know the P and we need to find the P inverse. Okay. So P is let me just recall here what is P. P is 1 1 1 0 2 2 0 0 3. So we can easily check that the determinant of P is not equals to 0, hence it is invertible. And I will just leave this as exercise. The P inverse you can calculate by finding its adjoint, and you just divide the adjoint by P. All right. So determinant of by determinant P, and determinant P is 6, right? You can calculate determinant P is equals to 6. So I'll just leave this as exercise. So what is P inverse is 1. I'll just directly write it. Minus 1 by 2, 0, 0 half, minus 1 by 3, 0, 0 and 2. All right. So yeah, no, sorry, 0, let me just 0 0 1 by 3. All right. Yeah, 1 minus 1 by 2, 0 0 1 by 2 minus 1 by 3, 0 0 1 by 3. Yeah, so this is P inverse. This you can take it as exercise. It's not very difficult, right? Okay, so now let's calculate the R matrix. So what is R then? R is nothing but the P is 1 1 1 0 2 2 0 0 3 into Q. Q is the diagonal matrix 2 0 0 0 4 0 0 0 6, and P inverse is 1 minus 1 by 2, 0 0 1 by 2 minus 1 by 3, 0 0 1 by 3. 1 second. 1 by 3. Okay, so let's multiply these matrices. So this is nothing but 1 1 1 0 2 2 0 0 3, and what is this? This is nothing but 2, and then it's a minus 1, and 0, and then 0. This will be 0, and then 0 1 by 2, so it's 2, and then 0 minus 4 by 3 plus 2 minus it's a minus 4 by 3, 6. Okay, and then the last one is 0 0 and 2. All right, so this is what we get. Okay, now let's multiply this again. Then we get, what do we get? We get 2 1 2 by 3 0 4 4 by 3, and last one is 0 the 0 and 6. All right, so this is the R matrix. All right. Okay, so what is given is this follows: R1AB is equals to 6 times 1AB. Okay, so if you multiply R with 1AB, you get 2 plus A plus 2 by 3 B is equals to 6. Okay, 4A plus 4 by 3b, okay, is equals to 6a, and this is 6b is equals to 6b. Alright, so if you simplify it, then you get a plus 2 by 3b is equals to 4, and 2a minus 4 by 3b is equals to 0. So if you solve this equation, this will give you 4a is equals to 8, so a is 2, and b is 4 by 3b is equals to 4, so b is 3. Okay, so I'll just complete it here itself. This implies a plus b is equals to 2 plus 3 equals to 5. So this is what we wanted to show. Okay students, so I will stop here now. Thank you for attending this session. In the next session, I will solve some more problems related with matrices and determinant, and I will also start a new topic which is on system of linear equations. Thank you.